This is the video solution to practice problem A that goes with sample problem 3.3 on page 83 of your text. In this problem, we will write and balance a chemical equation. We're told that the reaction is the combustion of propane, and then we're told the reactants and products. Just to be clear, in Chem 1251, you are required to know that combustion involves reacting a fuel with oxygen to produce gaseous CO2 and gaseous water. The fuel can change from combustion to combustion, but the oxygen, the O2, the CO2, and the gaseous water are things that we require you to know. In this problem, the fuel is propane. Propane is not one of the compounds that we talked about when we discussed chemical nomenclature in chapter 2. So I'll tell you that propane is C3H8. Here's the equation then that we will balance. C3H8 gas plus O2 gas yields, and here's our yield sign, the single-sided arrow pointing to the right, CO2 gas and H2O gas. The problem states that we're supposed to think about the water as being in the liquid state, but generally when combustion occurs, the water is converted to gas. Now we'll begin the balancing. In a reaction like this, or any reaction for that matter, a good general rule is to begin by balancing the atoms that are not hydrogen and oxygen first. In this case, that means that we will begin by balancing the carbon atoms. And when we say balance, that means to show the same number of that atom in both the reactants and products. Or think about the yield sign as a dividing line. You want the same number of atoms of each type on both sides. On the reactant side of this equation, we can count a total of 3 carbon atoms. On the product side of the yield sign, we can count 1 carbon atom. In order to make the number of carbon atoms the same on both sides, we'll need a coefficient of 3 in front of the CO2 product. That coefficient applies to all of the atoms in the CO2 and the carbon dioxide compound. And when we balance equations, we never change any of the subscripts. We only add coefficients to compounds. Now that the carbons are balanced, we'll need to make a decision about whether to balance the hydrogen or the oxygen next. I personally would rather balance the hydrogen next because I see hydrogen in one reactant, the C3H8, and in one product over here, the H2O. The oxygen atoms are split between the CO2 and the H2O in the products. On the reactant side, I see 8 hydrogen atoms total. On the product side, in the H2O, we find a total of 2 hydrogen atoms. In order to make these two values equivalent, we'll need to multiply the water by 4, or place a coefficient of 4 in front of the water molecules. And then with this change, both the carbon and the hydrogen atoms are balanced. Now we'll figure out the oxygen. On the reactant side, we find 2 oxygen atoms in the O2 molecule. On the product side, we see 6 oxygen atoms in the CO2. I got that value by multiplying the coefficient by the subscript of that oxygen. We also find on the product side 4 hydrogen atoms. That came from the coefficient of 4 times a subscript of 1. And that means that altogether we find a total of 10 oxygen atoms in the products. So when we balance the oxygen this time, we'll need a coefficient in front of the oxygen, the O2, in the reactants that will ultimately yield 10 oxygen atoms. Placing a 5 in front of the O2 will do just that for us, giving us 10 total oxygen atoms on the reactant side. We've balanced all the atoms in the equation. We find that the coefficient in front of the propane is 1, that one propane molecule reacts with 5 oxygen molecules to produce 3 molecules of carbon dioxide and 4 molecules of water. Please take a few minutes to complete practice problem B on your own and then check your answer with the key that's found on page 115.